12.4, day number 2, is going to be the second shortcut that we cover in 12.4. 12.4, day 1, we learned about a shortcut called the power rule, and we're going to be using that one to do the product rule. In the directions, they're going to ask us to find the derivative, and they're going to start out with some sort of function notation here. Usually it's the letter h, and that's because in the rule they do use f of x and g of x also. So we have h of x is equal to, and what we have, what your assignment is going to look like, you're going to have two things being multiplied together. We have one set of parentheses here and another set here. And what the product rule says is if you have a function where you have two things that are multiplied together, instead of doing the derivative, instead of calculating the formula for the slope of the tangent line the long way with the limit and the difference quotient like we did in 12.3, we can use this shortcut. In this shortcut, we have on the right side for the derivative of the original function, both f of x and g of x. Those are the two things that we started with. So the original rule says h of x is equal to two things being multiplied together. So in this problem, this first set of parentheses, that is like f of x. So that's what f of x is equal to. And the second set of parentheses here, that is the second thing that's being multiplied. That is like g of x. So our original function is two things being multiplied together, and then the shortcut for the derivative, h prime of x, is the derivative of function f. So that'll be the derivative of what I have here in blue, times the original function g, so what we have here in green, plus the original first function, so what we have in blue, times the derivative of what we have in green. All right, so here's what we're going to use and need. We need these four quantities. So let me get started by writing some of them down. We are going to need the original first function, which is listed here as f of x. So f of x, let me just copy that down. That is going to be an x to the 5th power plus 3x squared. We're going to need that, and that's going to go here in the formula. We also, though, need the derivative of that function. We need f prime of x. So let me calculate that and write that down here right underneath it. To do this derivative, we can use the power rule from 12.4 day 1, that shortcut that we just talked about. 12.4 day 1, the power rule says this: if you are taking the derivative of some terms that have a variable raised to a real number power, there's a formula for that. We take the exponent and we bring it to the front, so that's going to be just the number 5, and then we're going to have an x raised to a power, and we need to reduce the power by 1. So the first term in the derivative will be a 5x to the 4th. We need to do that with all of the terms. So next we have this 3x squared. I'm going to take the 2 and bring it in front. That's going to get multiplied by that 3 in front. So 3 times 2 is 6. And then we reduce the power by 1, which would be an x to the 1st power, or just an x. So the derivative of function f, the derivative of this set of parentheses here, is a 5x to the 4th plus 6x. And we're going to take that and we're going to put that in here for f prime of x in the formula. So on this right side, we need 4 things. I've listed 2 of them out. The other 2 things, let me list those out too. We are going to need to know what g of x is. That is the second set of parentheses. So just like I did a minute ago with function f, I'm just going to copy down that set of parentheses that is associated with function g. And then I will need g prime of x. I do need to know what the derivative of this green function is. But again, this isn't something we need to go and do need to do the long way. We can do this with the shortcut using the power rule again from 12.4 day 1. So taking the derivative of each one of these 3 terms, we have take the 3, multiply by the 7 in front, that's going to give me a 21, and then reduce the power by 1. So our first term in the derivative for function g is a 21x squared. We can use the power rule on these 2 terms, but we did say you might want to think of these a little bit differently. when we were doing 12.4 day 1. If you have a term that just has an x in it and you're going to do the derivative of that, you can use the power rule, but we kind of have a shortcut to the shortcut. If you have a term that just has an x in it, the derivative is just the number in front, which is subtract 5. And then here on the end we have plus 8. There's no variable at all on that one, and we said using the power rule, if you take the derivative of a constant term, like the number 8, you just get 0. So we could put a plus 0 here, but that would just drop off anyway. So the derivative of function g is 21x squared minus 5. All right, so when you take a look at our product rule here, we have our original function, and then we need 4 things over here on the right side of the equal sign when we do the derivative. We need to know what f and g are, those 2 functions. Those are the original functions. And then we also need to know their derivatives. So all I've done is made a list here. Every time I do one of these problems, I'm going to list f and then do the derivative, f prime. I'm going to do g and then list out g prime, and they're going to be in that order each time. Let me copy down what our derivative formula is again. I'm going to space it out a little bit. So we want to take the derivative of the original function. That is equal to, so I'm going to just copy this, formula down again right here, and I'm just going to spread it out a little bit so that we can line things up underneath it when we do the calculation. So the first part of this is f prime of x, and we're going to multiply that by g of x. And then we have that addition symbol that's there. Let me spread that out a little bit. And then we have function f, so I'm going to put f of x here, and then times the derivative of function g. So these 4 things, these 4 values that we have in this formula are listed here in blue and in green. So here we go. H prime of x, that's what we're trying to calculate. That is equal to f prime of x. F prime of x is this function right here. Making a mess of that. All right, that's f prime of x, or at least my attempt to draw a little red arrow next to it. F prime of x is 5x to the 4th plus 6x. Next, we have times g of x, and g of x is right here. So let me copy that one down. So it is times g of x, which is 7x cubed minus 5x plus 8. Okay. So in front of our addition symbol here, we have these 2 sets of parentheses, and if you list these out in order every time like I'm going to do, f and then f prime, g and then g prime, these are, see if I can make that a little better. These are the 2 inside values. So in front of the equal sign for this part, these are the 2 inside values. Then we get, and by inside I mean these 2, in the middle. And then we have an addition symbol in the formula. Let me copy that down. And then after the addition symbol, we have f of x. That is our original function f there. That's the very first one up at the top. So that is an x to the 5th plus 3x squared. And then we multiply that by g prime of x, and that's this bottom one. So that is 21x squared minus 5. So these 2 values here, these are the ones on the inside, the 2 middle ones, and then these 2 sets of parentheses, those are the ones from the outside, the first one and the last one. So if you are trying to memorize our product rule, which you'll need to for the test, we want to multiply these insides and then plus, and then multiply the outsides. This right here is the derivative of our original function h. It doesn't seem like that is a very big shortcut, but if we were to go through and do this out the long way, like we did in 12.3 with that limit and the difference quotient, you would see it would be much, much, much longer than this. So there is a lot to do, but it is way, way shorter than coming up with the derivative using 12.3. Right here. Here is what the expectation normally would be. The answers that are in the book, multiply these out and then combine like terms together. And I am going to do that for this problem, but for the test and for your homework, you can just stop at this point. So substitute in the derivative of function f and function g, plus substitute in function f and the derivative of function g, and then you can stop there. But normally, what the expectation would be to eliminate all of these parentheses and then combine like terms. So let me go through and do that. To eliminate the parentheses, I'll have to use the distributive property here. 2 terms times 3 terms. So I'm going to take the 5x to the 4th and multiply that by all 3 of the terms there in green. So 5x to the 4th times 7x cubed, that would be a 35x to the 7th. And then 5x to the 4th times a negative 5x is a minus 25x to the 5th. And then 5x to the 4th times 8 is a 40x to the 4th. So those are the first 3 terms. Now I need to multiply the 6x into all 3 of those terms. 6x times 7x cubed is a 42x to the 4th. 6x times negative 5x is a minus 30x. And 6x times 8 is 48x. Then we get the addition symbol. And then we have these two that we have to multiply together. This is a binomial times a binomial, so this is just going to be foiling. Multiplying that out, x to the 5th times 21x squared is a 21x to the 7th. X to the 5th times negative 5 is a minus 5x to the 5th. And 3x squared times 21x squared, that's a 63x to the 4th. And finally, 3x squared times negative 5 is a negative 15x squared. So we get all of these terms after you multiply that out. And then we need to combine like terms to finish the problem up. So taking a look at what we have here, highest power of x that I see are x to the 7th. So let me combine like terms. So I have a 35x to the 7th there and a 21x to the 7th there. So when I add those together, that's going to give me a 56x to the 7th. Let me see if we have any x to the 6th terms. I don't see any of those. So x to the 5th terms would be next. I see that we have an x to the 5th term here. And there's one here. And that's it, I think. So negative 25 minus 5 is a negative 30, x to the 5th. Then the x to the 4th terms, there are quite a few of those. There's 40 of them here, plus 42 more there, plus 63 here. So 40, and let me do these two first. 42 and 63 would be 105, and then plus that 40 would be 145. So 145 x to the 4th. Next would be our cubed terms, but there aren't any of those. There's one x squared term out here on the end, so I can just copy that one down. And then these two terms here would just have x's in them. So negative 30 plus 48 is positive 18x. So this is our final answer.